Okay, so let's look at this question here where we have two tanks connected by a common vent header. This is going to be equal molar counter diffusion. And we've looked at that in several examples in quizzes in class. So in this case, what that says is that JA star is equal to the negative diffusivity times dCA dZ. And we can approximate CA as XA times C. And since these are gases, XAP over RT. So that's going to tell me that I can say JA star is equal to more or less negative diffusivity of AB times P over RT, delta Z, and then delta XA. So most of this data is given, but DAB is given at 298 Kelvin and 1 bar. The temperature does not change, so I can stay with this 0.063 centimeters squared per second times the temperature ratio, which is 1 to the 1.75 power. But I also have a pressure ratio, and it's P1 over P2. The original data, P1 is 1 bar. I'm changing it to 1.5 bar. And so therefore the diffusivity under these conditions is 0.042 centimeters squared per second. Now then, if you take this expression and rearrange that to solve for delta XA, we end up with this expression, and JA star is given. R was given. T is 298 Kelvin, and I'm writing too large. And delta Z is 40 meters, but everything else is in centimeters, so let me switch that to 4,000 centimeters. And this expression is over 0.042 centimeters squared per second times my pressure, which is 1.5 bar. Okay, so my units, let's check those. So I've got centimeters squared here. That'll cancel with 2 of those. I'm going to have a centimeter here and a centimeter here, which will cancel with those centimeters squared. Mole here, Kelvin here, Kelvin here. Per second here, per second there. Okay, so everything is canceling, so this is dimension free. And so delta XA, when I plug this in, is 0.944. Now, the distance from here to here is 40 meters. So I'm taking 40 at this point and 0 at this point as my distance. That's in meters. So what are the x values that correspond with that? Oh, and that's negative 0.944. At this point, this is pure A, so x is equal to 1, and this is the one I'm looking for. And so this is equal to XA minus 1. And if I solve this for XA, I get 0.056, which turns out to be less than the 12%, and so therefore 0.056, no risk.